So here I'm going to go through a few questions, example questions that might come up in the mock exam or the real exam for Unit 1.1. So we've got here, Alicia has designed a computer using von Neumann architecture. Describe the purpose of two registers that are used by von Neumann architecture. Okay, so I'm going to do that classic thing of saying to you, look at the number of marks you've got available for that question. So that's 4. There's 2 answers. Doesn't take a genius to work out. You're getting 2 per box. So one of them's going to be name it, and the other one's going to be describe it. So I'm going to go with program counter as my first answer. And then I'm going to go with the accumulator for the second. The reason I'm picking these is they're quite easy to remember what they do. The other 2 options likely would have been the memory address register and the memory data register. But these, I think, are the 2 that are more obvious or more memorable. So the program counter holds the address of the next instruction to be executed by the CPU. Could put memory address, maybe make it a bit more full. Yeah, there you go. So the program counter holds the memory address of the next instruction to be executed by the CPU. I've got 1 mark there, 1 mark for that. The accumulator holds temporary values of any current mathematical or logical operation. For example, I might even give an example of this one. 3 plus 4 plus 5, it might hold 3, then 7, then 12. There you go. So you can see there that I've given 1 mark, 1 mark, 1 mark, 1 mark. Try to do that because the amount of students that really don't get that or just ignore it in the real exam, they get it now and then they go in the exam and don't do it at all and just write something stupid. So the CPU has a clock speed of 3.8 gigahertz. Describe what is meant by a clock speed of 3.8 gigahertz. Once again, it is 2 marks. So here is the important bit. You've got clock speed and 3.8 gigahertz. This was a real question in my first year at J277, and a lot of kids got 1 mark because they explained what clock speed was. Brilliant. But it says what is meant by a clock speed of 3.8 gigahertz. So clock speed is how many instructions are executed per second by the processor. I'll change that. A processor, so that's what a lot of them finished at. You could put measured in hertz if you wanted a fuller answer. A processor of 3.8 gigahertz could therefore theoretically, I always put theoretically because, you know, it's all that we'll learn how to spell, theoretically perform 3.8 billion instructions per second. Okay, giga means billion, mega means million. Try to remember those. In CPUs, it'll nearly always be billion. And yeah, in most things, it'll be billion now because we've moved on. So giga means billion. So there you go, I've got 2 marks. Obviously, it looks like I haven't filled out the box, but don't remember I'm typing and there's only actually 4 lines there. So realistically, it would look more like that and therefore have filled up the area. But don't just worry about filling up the area. Think about the marks. Mark yourself. 1 mark for that, 1 mark for that. When you see 2 marks, think where are the marks here? I can't get 2 marks just explaining clock speed. It literally says 3.8 gigahertz. So if you don't put 3.8 billion, you're not getting a mark. Okay, this is 3 marks. Okay, so basically I've got to make 3 points. My computer has a quad-core processor, so it will run twice as fast as a computer with a dual-core processor. Explain why this statement is not always true. Okay, so you've got 3 marks here. You could even, you know, mentally, I might not do this on the actual paper. I might write them out. So, you've got 3 marks. How are we going to answer this? A quad-core processor has 4 processors in it, and a dual-core processor only has 2. In theory, that means it should run twice as fast. However, this is not always the case. So I've opened up by writing out, you know, I've said that for, you know, explain that the reason it's twice as fast is because quad means 4, dual means 2. Delete that, that's my first mark. I'll just write them on 3 different bits. Each core in the CPU can perform an instruction separately. However, if there is not enough instructions to go around, then some of the cores might remain unused. That was really good typing. If the user is not loading many applications, then there might not be enough tasks, oh my god, to utilize all of the cores, meaning it will not run twice as fast. Okay, so okay, just whatever. Right, so think about this one. This is a more difficult one. It actually was. I was writing, I was thinking, oh, this is, you know, a little bit more challenging. So I explain what the quad core processor and what a processor is. So I do the explanation of like, what do these things mean, right? Quad means 4, that means dual means 2, processor means instructions. So in theory, you know, this is not always true, but you talk about why it could be true. Then I talk about the fact that if they're unused, see, a lot of kids would do this. They would stop there and they think, well, I've explained that there's not enough instructions to go around. That's brilliant. But then you need to talk about the fact as to why there might not be enough instructions to go around. So if the user is not loading many applications, see, that's the bit. See, here I'm saying not having enough tasks means that the CPUs don't all get used. But there's where I'm explaining an actual real life situation where that can happen. If the user is not loading many applications, then there might not be enough tasks to utilize all the cores, meaning it will not run twice as fast. I'm very explicit in the last one. So think about the 3 steps. I explain the situation. I talk about why it's not necessarily going to be twice as fast in the middle bit, because, you know, if they're not being used, why it's not going to be used. And then I give a specific user, a real life situation where, why would there not be enough tasks? Because just saying there might not be enough tasks is great, but why might there not be enough tasks? Because they're not loading enough applications. So hopefully you can get a gist of how you answer some of these questions. I can't do all of them. And the first section has got actually quite a lot. If we look at it, it might ask you to name quite a few things and say what they do. So obviously, you know, there's no point me going through those answers. I didn't answer any on embedded systems because they often just ask you for the benefits of maybe an embedded system. And that's really listing the fact that, you know, they are cheap to design, cheap to run, cheap to build, low power, etc. And they might ask you for examples of embedded systems, and you should know those and what these things mean. But they're just memory recall of certain things. Another common one, I'll just do that one actually myself. I'll make a new one actually, is cache. They talk about explain why increasing cache size might increase the CPU's performance, right? And this could be, say, 3 marks. It could be 3, it could be 2, whatever. So this is a big problem because people then explain what cache does. Cache is a super fast piece of memory storing recently used data or instructions. Hopefully you know that. When the computer needs information from RAM, should put processor really, it is often the case that it has been recently used. It is therefore quicker to get this data from cache rather than RAM. Brilliant. You've got 1 mark. And the reason is, you might get 2, that it says explain why increasing cache size. So you need to answer that. You're not answering that question. It's always good to explain what the things are. And so explain what cache size is. Explain why it increases CPU performance. So these are your 3 marks. What is cache? Why does cache increase the performance? Why does increasing the size increase the performance? So that's the 3 things you've got to get there. By increasing the cache size, we can store more recently used data, making it more likely that the data can be obtained from the faster cache, increasing or decreasing the time taken to execute the instruction. There you go. So then my 3 parts to it. What is cache? why does it affect CPU performance, and why does increasing the size of it affect CPU performance? So try to think about that when you're doing it, because it's really annoying when you know the kid knows the answer, but they don't get it here. Because don't forget, you want to get, every time you know the answer, you want to get 4 marks, because you're always going to catch a question you don't know the answer to, or you've got no idea. So then you're getting 0 in a question that might be worth 4. Well, that means you don't want to lose sort of 1 mark on 4 previous questions when you did know the answer. So have a look at this, and then you can have a go at the next units.